Hello everyone and welcome to Statistically Speaking. Today we're going to talk about expected value. And now what is expected value? Well, you can hear on the name, it's a value that we expect. But what does that mean? Well, the expected value, you could say, is the population mean. We know how to calculate the normal mean. We just take the sum of all our numbers divided by the amount of numbers. But expected value we can calculate in other ways because most times we don't have a fixed numbers of trials or numbers. We just know what are the probabilities for each number. So let's look at the different ways to calculate the expected value. The first example we're going to look at is when we have some x's and some probabilities for these different x. So we have that x can only take on the numbers 0, 2 or 5, and it has these different probabilities for taking those numbers. So how we then calculate what is the expected value, what is the mean for this whole population, if we know that these are the true probabilities? Well, the formula we're then going to use is expected value for x is equal to the sum of our x's, xi, times the probability for xi. And then we have that I goes from 1 to, we can use k. It doesn't really matter what letter you put, just that we're gonna have for each single one of these, we're gonna have in here. And from here, we simply just calculate it. So we're gonna have the expected value for x, in this case, is 0 times 0.2 plus, because it's a sum, 2 times 0.3 plus 5 times 0.5. And then we just put it into the calculator and see what we get. And we're gonna get 3.1. So that is how we calculate the expected value when we have a case like this. One thing that is important also is that these probabilities needs to be the sum of all our probabilities for xi needs to equals 1. If it doesn't, then we're missing something. But this is in a case where we have a fixed number of how many x's we can get. But what if we would have a continuous situation where we can't pinpoint each x because it could be any decimal and all that? Well, so here we have a continuous case where x's don't have to take on a few specific numbers. It can take on any value that is above 0 in this case. And this distribution is an exponential distribution. There will be another video of that later. But if we're gonna calculate what is the expected value of this, in this case we would take the expected value of x is equal to integral from minus infinity to infinity for x f of x dx. In this case, we don't have anything from 0 to minus infinity, so in this case we would have from 0 to infinity. And then we just put in our numbers. We put in x, and then we would put this here. And then we would calculate that. I won't do it here. But we would get that the expected value for this function would be 1 divided by this lambda symbol. And this lambda it's a constant, which we decide when we pick the distribution. So that is an example of a continuous case. But how would we calculate if we would have, let's say we have a g of x that is equal to x squared. And we want to calculate the expected value of g of x. Well, we still use this function, but instead of x, we have another function. So, this would be, just as before, an integral over the whole spectrum. And instead of x here, we put g of x, and then f of x dx. And we simply see, okay, where we put an x here, we instead put a g of x here. I haven't calculated this though, so I won't put what this will become. But that is how that kind of situation would work. You would put the g of x instead of the x in this spot. And then let's look at some different counting rules. So I have here, we have one constant and we have two variables. And then we have different scenarios that we can get. So what is the expected value of a constant? Well, if we have a constant, we expect the constant to be the constant. So that is equal to a, the constant. And what do we have if we have an expected value of a constant times a variable? Well, we will have the constant times the expected value of the variable. And what happens if we have two variables that we sum together? Well, we will have expected value of x plus expected value of y. And then what happens when we have expected value of x times y? Well, this is a little trickier because we can't just take expected value of x times expected value of y without thinking about it. That is generally not the case. Let's say, however, that x and y are independent. So we have that x and y are independent, meaning that they don't bother each other. Let's say we throw a dice and we toss a coin. Will the coin flip determine anything about the dice roll? No. They don't do anything to each other, meaning they are independent. What one does doesn't affect the other one. And if that is true, then we have that the expected value of x times y is expected value of x times expected value of y. If they do depend on each other, let's say the sales of ice cream and the weather, well, if it's sunny, we're gonna sell more ice cream, meaning that they do depend on each other. In that case, we cannot just do this. So what do we do when they are dependent on each other? Well, in that case, we pretty much use the formula we had at the beginning. So, we're gonna get that the expected value of x times y is equal to double sum, meaning just all the different possible combinations. And we have our xi and our yj. We just need different notations just to make sure we get every single possibility. Times the probability for xi and yj. So what is the probability that we get that combination? And then we just calculate that. So this is when they are independent, and this is when they are dependent. But what do we do when we don't know the real numbers? We don't know the real probabilities of everything. Well, what we can do is that we take a sample or something like that. So we take a few numbers from all the numbers. Let's, for example, we would look at the height of people in Sweden. Well, to measure the height of everyone in Sweden, well, that would be a lot. But what we can do is that we take a few random people and measure their heights, and then we take the mean of those, and that would be our estimation of our expected value. So, in an earlier video, I talked about x bar, and x bar is an estimation for the expected value of x. So if we can't calculate the real expected value, we can often calculate the mean. So we use that instead to have an estimation for what the expected value might be. So that was some explanation about expected value and the different formulas. But are these the only formulas to calculate expected value? No. These are the general formulas, but with different distributions we can have different formulas to simplify things. But these are the formulas that always work, but in some cases there are simpler ones that results in the same thing. But this is all I'm gonna talk about today, and we're gonna check on the other simpler ones and all that in other videos when they become relevant.